Hello, welcome everyone. Welcome back to my channel. Today we are doing proving similarity. In just previous video, we have seen what are the similar figures. What are actually the conditions that make two figures similar figure. Now, in this we will be doing proving similarity. That means two different figures will be given and we have to prove that they are similar. So, same thing we have to keep in mind that two shapes are said to be similar if that you can see I have written here that all the corresponding angles are equal. The corresponding angles in the previous video I have explained that part, and same thing is here that all the corresponding angles are equal. They have to be equal. And the second is all the corresponding sides should be in ratio, and that ratio should be a constant ratio. I have given the name that was a length scale factor, which means if there are two figures, one side of one figure is twice the other side. So every side of the same figure will be 2 times of the other figure. That means, suppose I'm talking about these two figures. If I'm saying this is 10 centimeters, so this will be 20. You can clearly see that the bigger one is twice the smaller one. It means that every side will be twice. So if, say for example, this is 4, then this will be 8. So every corresponding side of the bigger one will be twice in this case. So same thing I'm describing here, that means they bear the same constant ratio. So all corresponding sides are in ratio, or you can say they bear a constant proportion. If you are going to prove two geometric figures, not necessarily only triangles, it can be like hexagons or it can be any three figure, any figure. If you are going to prove that two geometric figures are similar, there are two conditions that you have to follow. The first one is the corresponding angles should be equal. If you will be able to prove the corresponding angles be equal, you would be able to prove that two different figures are similar figure. And second thing is all corresponding sides should be in proportion. They bear the same constant proportion. Now, if I talk about specifically proving similarities in triangles, then there are certain rules by which we can prove two triangles be similar triangles. The first one being angle. So angle, that means if you'll be able to prove two corresponding angles equal, you can prove that basically two figures are similar figures. How? Say for example, I say this one be 90 degrees and this one be 90 degrees. So we have proved that both the corresponding angles are equal. Similarly, if we have proved that this one be 30 degrees and this one be 30 degrees as well. So if I'll apply the angle sum property says that sum of all the angles of a triangle is always 180 degrees. So if I apply angle sum property in my smaller triangle, I'll get to know that this angle will be 60 degrees. Similarly, if I'll apply the same angle sum property, I'll find in the bigger triangle, I'll find this be 60 degrees as well. It means that if two corresponding angles are equal, the third angle will be automatically equal, obviously by angle sum property. And if it will become automatically equal, that means yes, all the three corresponding angles are equal and hence this is a similar triangle. So this is the reason even if you'll be able to prove two corresponding angles equal, we can prove that the two given triangles are similar in nature. Moving on to the next, which is angle. If in a given triangle already you can see that all the three corresponding angles are equal, we can prove that it's a similar one. That means if this is 90, this is 90, if this is 30, this is 30, this is 60, this is 60, and already it's given. See, more specifically, I'm talking about given thing. Like in angle, if only two corresponding angles are given already and they are equal, we need not to find the third angle because that will be automatically equal. So we need not to do that extra burden. We don't have to do that. We can directly prove that they both are similar. Now angle will apply when all the three corresponding angles are given. In that case, by AAA, I can prove that both the triangles are similar in nature. Moving on to the next one, side angle side. If suppose in two triangles, not all the corresponding angles are given, just one corresponding angle is given and that are equal. But here the sides are there. You can see the sides have taken the space here in this case. So if sides are in proportion, not equal, they have to be in proportion, then we can prove that they are similar. Which means if I'll say that this is 4 centimeters and this be 8 centimeters and this be 12 centimeters, then this will be 24 centimeters. So obviously they are bearing the same ratio, which is 2 actually. So 12 over 24 is equals to 4 over 8. That is going to give you the same proportion, and the corresponding angle, the important thing is which corresponding angle, the corresponding angle which is included in these two. We have proved this side, this side, this side, this side. So angle should be in between that. That means this angle. If it's like this, then we can prove that yes, these two triangles are similar in nature. And that's why its name is side angle side. So side, then angle, then side. It's like the name is given properly according to the order. Moving on to the next, that is side similarity. If there's no angle, we just have kept angles out of this picture and now it's only about the sides. And if all the three corresponding sides bear the same constant ratio, then we can prove by side that these two triangles are similar in nature. They don't have to be equal. Keep that in mind. If you will make them equal, the triangles will not be similar. They will become congruent. So congruency is proved by equality, because congruent figures or congruent triangles are those triangles that their corresponding angles as well as their corresponding sides are equal, whereas similar triangles are those triangles where the corresponding angles are equal but their sides are in constant ratio. So similarly, by side similarity, we have to prove that AB over ED, that means this and the corresponding side this, when I'll take the ratio, is equals to, because in numerator I am using the sides of a smaller triangle, so every time when I'm finding the ratio, the smaller triangle side should be in numerator, which means BC over EF, which is the hypotenuse of both the triangles, and AC over DF, and if they are bearing the same constant ratio, so by SSS similarity we can prove that two triangles are similar in nature. So these are four important rules for similarity, and if you can see these things in a given triangle, we can prove that two triangles are similar in nature. Now moving on to the question. The question 1 says there are two right triangles given in the figure that we can clearly see. If AB is equals to 4 centimeters, this is 4 centimeter, and AC is equals to 10 centimeter, this one is 10 centimeters. FE is 30 centimeters, this is 30 centimeters, and then we have to prove both the triangles being similar. So we have to prove that both the triangles are similar. One more thing, DF is already given, this one. So now we just have to keep in mind, I told you four similarities. First one was angle. Here only one angle given. Which one angle given? They have already mentioned two right triangles. So two right triangles, that means you can clearly see they both are right angled at A and F respectively, and these two are corresponding angles. So we know that angle A is equals to angle F. I can clearly understand I can't use AA because no two angles are given, just one. I can't use that. Angle, not at all. Side, 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 not at all, because not all three sides are given. So we are left with one, that is side angle side. So now we have to see whether this corresponding sides are bearing a constant ratio or not. When I'll divide DF over AB, so I'll get 12 over 4, which is 3. Similarly, when I'll do FE over the corresponding side AC, that is 30 over 10, that will give me 3. Yes, they are bearing the same constant ratio. So by side angle side, they have to be in that order. I can prove that these two triangles are similar. So I can say by SAS similarity, they both are similar in nature. Moving on to the next question. Here the two trapeziums are given. Just keep that in mind. You can't apply SAS or AA rule in trapezium. That was for specifically for triangles, not for any other figure. For any other figure, it's the same. Prove the corresponding angles being equal, or you can prove all the corresponding sides be bearing the same constant ratio. If we read this question, it says in the figure given above, angle A is 80 degrees. So this one, angle A is 80 degrees. Angle C is 120 degrees. This is 120. Angle H is 100 degrees. So this is 100 degrees. And angle F is 60 degrees. This one given. Then state whether these two trapeziums are similar or not. So there's no involvement of sides, so just forget about proving them in constant ratio. We just have to stick to prove all the corresponding angles being equal, which means we have to, first of all, we have to find all the angles of the trapezium, and then we have to compare whether the corresponding angles are equal or not. First of all, you should be aware of some basic properties of the figures. For trapezium, we know trapezium is a figure in which two opposite sides are parallel in nature, whereas two other sides are non-parallel in nature. Using this property, we can calculate the other angles. That means we know that opposite sides are parallel. So this side and this side are parallel. This one and this one is a transversal. And in this case, if these two lines are parallel and this one is transversal, then this angle and this angle will form an interior angle, which means clearly this angle and this angle add up to 180 degrees. So I can say angle A plus angle D is equals to 180 degrees. This is the property of trapezium, which gives me angle D as 180 minus 80 equals 100 degrees. So this will be 100 degrees. Similarly, I can apply the same property. That means these two lines are parallel and this one, this parallel and this one is transversal. Then this one and this one, they both are interior angles and same, they add up to get 180 degrees. So I can say angle C plus angle B is 180. So angle B will be 180 minus 120, which is 60 degrees. Now, this is what I applied in trapezium ADCB or ABCD. Similarly, if I'll apply this in trapezium EFGH, then I have to do the same thing. Two lines parallel, this is transversal, and by interior angles, sum of interior angles of two lines parallel and being cut by a transversal is always equals to 180 degrees. So this will be again 180 minus 100, which will give me 80 degrees. So same, I'll apply angle H plus angle E is equals to 100, which makes angle E is equals to 100 minus 180 minus 100, 180 minus 100, which will give me 80 degrees. And similarly, angle G plus angle F is 180 degrees. That means angle G will be 180 minus 60, which is 120 degrees. Now, if you look into the corresponding angles, they are equal. Obviously, angle D is equals to angle H, angle C is equals to angle G, angle F is equals to angle B, and angle E is equals to angle A. So in this way, I can say that all the corresponding angles are equal of this trapezium, and hence this trapezium is similar. So these both trapeziums are similar figures. So that's it for today, and before I end this video, I have to say that I am running the classes, GCSE batch classes, the revision classes. So it's just £6 per hour. So you just need to just email us at exactadmin@gmail.com, and it's for so in science, triple science, combined science, maths, and for English, the batches that we are running. And you just like at £6 per hour is like pretty affordable, and they're highly interactive classes. You will be provided with the worksheets, flashcards, and you can say the mock test, everything will be included in it. Also, I'm running the Easter revision batches that are only for 15 days starting from today itself. So if you want to enroll in that as well, you can just, and that they are pretty affordable. Each day you have to give 1.5 hours for each subject, and for straight 15 days, and it will cost you just £90 for the complete course. And if you want to book for online classes, you want to book for the free demo, obviously there will be free demo for every type of classes. So if you want to book the free demo for any class from year 1 to till A levels for any subject, whether it's maths, triple science, combined science, or business studies, English, computers, history, geography, we provide classes for all the subjects. You just have to email us at exactadmin@gmail.com, and we'll coordinate there. So that's it for today. Have a great day. Bye. Take care.